Hello everybody, welcome to Statistics and Theory. In this video I'm going to demonstrate how to use Jamovi for basic statistical analysis. If you have not downloaded Jamovi, please go to this website and I'll leave this link in the comment section of the same video so that you can download it. I suggest that you download the most current version, which currently is 1.8.1. In addition, since I'm going to discuss concepts like mean and standard deviation, skewness and kurtosis, and a lot more, I suggest that you take a look at this book which we published in 2019, especially the first chapter, which is about item analysis and language assessment. It provides an overview of some of the concepts that I will cover. One more thing is that since some of you have asked me what sort of skewness and kurtosis range should we look into when we are making sense and interpreting skewness and kurtosis values. In this paper, we have very briefly touched on that and provided some references, but in the video, I will also, in this demonstration, I will also talk about those ranges and some of the references that you can mention in your papers. So this is how Jamovi looks like. You might not see some of these modules because you might have not installed them on the main interface. So in order to install different modules on Jamovi, you can just click on module and go to Jamovi library, and you'll see three options here: sideload, available, and installed. So available includes those modules that you have not installed yet. So you can scroll down to see what kind of modules you would like to install on your Jamovi and just click on install, and it will be installed. Make sure that your internet connection is reliable, because some of the modules are pretty large and take some time to install themselves on Jamovi. Next one is if you want to find out what sort of modules you have installed on your Jamovi, you can go to installed tab and see the list of the modules that have been installed. As you see, I have already installed 3 of them. In one of the videos that I will present in the future, I will certainly talk about item response theory, and in another one I will talk about meta-analysis for Jamovi. Now let's get started with our analysis. What I'm going to do, I'm going to use is the exploration tab. Before that, I have to load the data set. I go to this menu, which is represented by 3 lines, and click on it. I want to open a data set, so I easily just click on open, and I'm given 2 options: this PC and data library. If you want to open your own data set rather than open any data from the data library, you can choose this PC and go to browse right here. I hope you can see that right on top, and click on browse, and this window will pop up. Then you can just find your data set on your machine and open it. The sort of data files that are supported by Jamovi are right here in this drop-down menu. Let me drag it up a little bit. Okay, in this drop-down menu you can see quite a few different types, like the Jamovi file, OMT, and I think this is commonly used in many data analyses that you might have done in the past: CSV and TXT, and also Excel and SPSS files, as well as R files, Stata, SAS, and JASP, which is another user-friendly and freely available package, which I will talk about in the future. So just choose this sort of data set that you want to open and find it on your computer through this menu, and really just click on open, and there you will be ready for the analysis. For this presentation, I would like to just use the data library of Jamovi because there are some very interesting data sets here. So I'd like to start from Big 5. They're referred to 5 psychological or psychology styles, if I'm not wrong. So I'm going to click on this, and the data file will be opened. Well, on top you see that there is this data button. You can click on data, and if you want to look into the properties of these variables that you have already included, you can click on setup and go through each of them one by one like that, and you will be moved forward and backward in this way. The other way is just to click on these arrows and move back and forth between your variables. What you can do here is to change the name of the variable. You can also include a description if you will, and the measure type is very important in Jamovi. You can change the measure types. You've got nominal, ordinal, continuous, and sometimes your measure type is just your variable type is really just an ID which you can choose. Since in this analysis the variable has got decimals, as you can see, the data type has been chosen as decimals. Otherwise I would have chosen integer, or in some cases it could be text. One of the interesting things about Jamovi is that it can also include text, but when you choose text, it automatically the measure type automatically changes into nominal. So I'm going to just change it back to decimal and decimal continuous. I think that's more or less everything about it. If you want to add any variable, you can add this, or if you want to delete it, you can just delete any variables if you like, and so on. So I'm going to click this to hide those pieces of information about the data variables and go back to Jamovi itself. Alright, so I'm going to toggle to analysis or analyses, and in this tab you can see all the statistical analyses that we can run on Jamovi, and a lot more, as I said, in module can be found in the modules tab. And for the analysis, let's get started with exploration. It's a very useful tab. It's very useful. So I'm going to click on descriptives, and I will be provided with two options, variables and split by. So I'm going to choose all of these variables because I want to get some descriptive statistics for them, and move them to the variables box here, and immediately some basic descriptive statistics will be generated for me. It's really very user-friendly of way of presenting the results of analysis. I have two buttons here. I click on statistics, so this menu will be extended, and what you can choose is anything really that you like to include in this table, and the table will be updated pretty fast. For example, I want to include mode, and mode will be included immediately, as you see from here. And sum will also be included, as you see from here. And then, of course, two very important statistics which I am going to spend some time talking about are these two, Skewness and Kurtosis, because they're really something that I want to examine. As you know, Skewness and Kurtosis are used for normality assessment of the data. In addition to these, some books and authors have suggested to use Shapiro-Wilk. So Shapiro-Wilk will generate two statistics. One is the Shapiro-Wilk W or omega, and then Shapiro-Wilk P. I think Shapiro-Wilk W is something that's commonly used to call it. And anything else that you like variance, range, and IQR, SE mean, that's standard error of measurement. All right, so let's go through these statistics and see what we want to make sense of. We have mean, median, and mode, which are right here, mean, median, and mode, and we have no missing values, and the n sample size is 500. So the mean and mode and mean, median, and mode are the three measures of central tendency, which are pretty useful. In a normally distributed data, these three are exactly the same. So as you start to deviate from normal distribution, these three also start to deviate from each other. So I don't see a very huge deviation in these three statistics for neuroticism and extroversion, etc., on the rest of the variables. So the highest mean belongs to the, let me say, this one, 3.59, which is openness. The sum here refers to the summation or the addition of all of those scores on each of these categories. So the highest sum here is 1797, which pretty much is in line with the mean, which we saw before. In a sense, since this is a questionnaire, and I've discussed this in other videos, it indicates that this category, or this scale, if you will, is easier to endorse. So that's why people give it higher scores, as opposed to something that has a lower mean score, such as neuroticism. So this is not as easy to endorse as openness, meaning that those people who answered this questionnaire were feeling more comfortable giving higher scores or endorsing this item highly, these items, because this is an addition. This is the summation of several items, compared with the items that were measuring neuroticism. Now, for standard deviation, and as you know, standard deviation is a something like a yardstick, which basically provides us with a unit that shows how far different data sets fall on on the two sides of the mean in the sample or in the population. Here we have a yardstick as big as 0.453, whereas the standard deviation here is smaller for extroversion. What this indicates is that the amount of scatteredness of the data around the mean in neuroticism is larger than the scatteredness of data in extroversion. You can actually interpret the rest of these statistics in the same way. So there are more people in neuroticism. There are more people who chose high, mid, and low levels of neuroticism, although on average the mean is pretty low. But since standard deviation is pretty small, and here under openness is much smaller, we can say that there is some evidence that people are more homogeneous when it comes to answering questions which measure openness compared with the wide scatteredness of answers under neuroticism. Now, the minimum and maximum scores are also these are the mean scores, minimum mean and minimum and maximum mean score per participant. The minimum is 1.65, which means that there was one or two or more people whose answers on average added up to 1.65, and there were some people who had a larger maximums. Who had a larger mean score that was 4.38. So this is another way of looking at the scatteredness of data, but the best one will still be standard deviation because it's a standardized unit. Now, when it comes to skewness and kurtosis, I think we might have seen different criteria. Basically, skewness is how much tilted the distribution is. So if your distribution has a so-called a leg towards the left side or the right side, then the skewness will get inflated. Now the question is how to interpret the statistics. Well, you might have seen this in different textbooks too. You might have seen different criteria in different textbooks. So what I suggest is a textbook like Klein's in 2015 or 2016, in which he discusses structural equation modeling, assumes that skewness between -2 and +2 indicates normality of the data. For kurtosis, we're a lot more liberal, and if the kurtosis falls between -7 and +7, according to that textbook, there is evidence for normal distribution. But in other textbooks, you might have found different statistical ranges, for example, -2, +2. I personally go with that -7 to +7 range, and this is something that we have discussed in this paper quite briefly if you're interested to take a look and see what kind of references we have cited there. Okay, then comes to, let's take a look at these ranges, and as you see, everything falls between -2 and +2 for all of the 5 scales. Neuroticism has got a skewness of 0.273. Extraversion has got a skewness of -0.388, and so on. And especially this one, conscientiousness is pretty much close to 0. This is one of the best statistics when it comes to skewness among these 5 categories, 5 let's say scales. And then we have kurtosis in the same way. You can see that there is a range, but none of them is really exceeding the range that I mentioned. That's -7 and +7, and even they're not even close to 1 or unity. So there is quite a lot of evidence here for us to assume that our data is probably normally distributed. However, when it comes to using Shapiro-Wilk statistics, let's take a look at the p-value, because this WW makes sense only if you look at the p-value. So if you look at the p-values which are smaller than 0.05 or 0.01, like this and this here, these two scales can be viewed as deviating from normality. So we're looking at a discrepancy between the results of Shapiro-Wilk p-values and skewness and kurtosis values. So my suggestion is that we can stick with skewness and kurtosis in this case, because Shapiro-Wilk tests are more reliable when your data fall between 50, the sample size falls between 50 and 300. So if it's larger than that, the precision of the test tends to get worse, and as a result I prefer to look at skewness and kurtosis statistics. Now the other thing we can look at is the plots. There are a lot of wonderful plots. I can start from a histogram. A histogram is like this. So we have neuroticism, for example, for this one, on the horizontal axis, and the density of neuroticism on the vertical axis. And this seems to be something like a normal distribution to me, really. So this, together with the statistics of skewness and kurtosis, which we saw here, indicate that this scale of neuroticism is most likely normally distributed. So I'm going to click density as well in this section, and I'll get a density plot. In this time, density plot has been superimposed on the normal distribution itself. But this will give us a very interesting presentation of the normality of the data. And actually, every scale has been separated from the rest of the scales, and there's a density and histogram for each of them. Now, we can get box plots, which are pretty useful too. Let's take a look at, for example, the box plot for skewness, for openness. I have talked about box plots in 2 other videos. I will leave the links under this video, just in case you like. So, in a long story short, 25% of people fall in this area here. 25% fall here, 25% here, that's 75, and 25% of the data falls in this region. So that's how the data is distributed in a box plot. Now we can add a violin sort of boundary, and this makes it more interesting because it simply shows that the amount of data that that is found in this region is relatively more than the rest of the regions in this. Now let me just show you how data is distributed. By clicking on data and just keep it as jittered, you see that the data is now very clearly distributed more heavily. Let me see if I can draw some lines here to show how data is distributed. Okay, so as you see, the data is distributed in this region. Oops, that's this quite thick. Okay, and yeah, this is better. So in this region, as you can see, the highest amount of data is distributed, and that's pretty easily observable in this graph. Okay, so the next thing you can also generate is a bar plot. By clicking on bar plot, you can get a bar plot like this. For data like openness, since we only have one variable here, bar plot might not sound very useful. So I'm going to unclick it, and anything else like QQ plot can also be examined. QQ plots also give us some information like this about whether the data is normally distributed or not. We've got theoretical quantiles on the horizontal axis and standardized residuals on the vertical axis. So the closer these dots are to this line, the line which basically represents the normal distribution, the higher the likelihood of the normality of the data. That's how we interpret the QQ plot. We have some deviations here on top of this this graph, and some deviations from normality at the bottom, but altogether, as we saw, let me see if this is extroversion. Well, as we saw earlier, the extroversion is still normal distributed according to the statistics we saw. Now, one last thing is we can include the mean score, the mean or represent mean statistics of the variable in the box plot by clicking mean, and you see it's now we can see the mean of the sample in this plot. So this is how we can generate a basic statistical analysis in Jamovi. One last thing I would like to add is that you can also split your output. For example, if you have a gender, you can see if males and females have more or less the same normal distribution. Let me see if you can find another data file here. Let's look at Anderson's IRIS data. This is a famous data that's used in many statistical analyses, especially in some demonstrations. So let's click on descriptives, and I'm going to move everything to variables and species. By the way, species is, let me toggle back to data. Species, as you see, is a nominal variable. I click on setup, and I'll see species here is nominal, and the type of the text is the type of the data has been specified as text, and that's very obvious here, as you see that there are different types of flowers here. Now I go to analyze, and I click on this side, so this window will come back. Then I move species, which is a nominal variable, into split by. So now I get all sort of statistics, for example, skewness and kurtosis, for not only every variable which are here, but also for species. For example, for setosa, the sepal length is 50. This is number, sorry. The for setosa, let's say the mean of sepal length is 5.101, and for width is 3.43, and petal length is 1.46, etc. So across different species, we'll get different distributions and different statistics. Now we can also generate different plots. Let's generate a histogram and a density graph for these different species. As you see, this is for the first species, this is for the second one, this is for the third one. As you see, they're quite different in terms of their mean. The next one is the width variable. This one was the length variable. This is the width variable, and these two species are more similar. This is versicolor and this is virginica, which are more similar, but and in the same way, when it comes to petal length, the virginica and versicolor species are more or less closer to each other in terms of the distribution and the normality, whereas the setosa is pretty far away from these two. And in the same way, you can create all other graphs such as box plots, and you can include everything that you would like to. Let's just take a look at one of the box plots before we finish this video. So this is how they are compared with each other. This is really cool because in other statistical software packages that I've worked with, I haven't seen cool graphs as cool as these. So I think they're almost publication ready, and if you want to include them in your reports, they will be very attractive for readers and as well as for the reviewers. So this brings me to the end of this video. I hope you found it useful. If you have any questions, you can write it in the comments section. Have a great day.